This is the video for section P6, complex numbers. A complex number is any number that can be written in the form of a plus bi. The a part, where you don't have the I, is called the real part, and the b part, where the I is called the imaginary part. So you can have any combination of numbers. It can have both a real and an imaginary part. So we could have 2 minus 5i. Got the real part is 2. And the imaginary part is the minus 5i. We could have a pure imaginary number, so we could have something like 7i, where the a part is simply 0, and the b part is 7i. Or you also can have a number with no imaginary part, so I could have the number 10, where my a part is 10, and the b part is 0. Over on the right, you can see that we've got a couple different powers of I. Now, I is defined to be the square root of negative 1. That's where the number comes from in terms of the imaginary part. If we take I and we square it, take negative 1 times root negative 1, then we get I squared is negative 1. Right? Now, if we continue in that pattern and we take I to the third, that's the same as I squared times I, and with I squared being a negative 1, then we're going to have negative 1 times I, so that I cubed is negative I. Negative 1 times I, or negative I. And then, of course, we come down to I to the fourth, and we can break that down as I squared times I squared, which would relate to negative 1 times negative 1, and therefore I to the fourth is positive 1. If we do other powers of I, they can all be broken down in terms of one of these. So as we'll see in tomorrow's lesson that finishes up the section, we'll be able to rewrite powers of I other than just I to the first power. Today we're going to go and do some calculations just with basic powers of I. Down below we've got some examples where we're going to take some expressions and rewrite them in terms of I. If we're taking the square root of a negative number, we can rewrite that number as though we had negative 1 times 49 under the radical. And then using our properties of radicals, we know that can break down as two separate radicals multiplying. And here we're using our definition of I as square root of negative 1 is I, and then we simplify the square root of 49 is 7. So in radical negative 49 simply rewrites as 7i. In the second example, we've got two parts, and that radical of negative 24 can be written as negative 1 times 24. The 5 is still out in front, and we're able to take out the I for the square root of negative 1. And the square root of 24, we go back and we simplify just like we've done before with our radicals. It's 4 times 6, so we're going to be able to take out a 4. So write that as 5 plus 2i radical 6. And that takes care of the second one. We have it in a simplified form. Alright, now taking a look at the next couple, we've got a problem here that's a subtraction problem. And it looks just like a regular polynomial, and in effect that's how we treat it. We treat it as though we're combining a polynomial using subtraction, and we can treat the real parts of the complex number and the imaginary part as though they were variable parts. So we can rewrite this one in terms of 2 minus 7i minus 10 plus 3i. The negative sign is simply distributed through the second complex number, and we come back and we combine the real parts, giving us a negative 8, and we combine the imaginary parts, leaving us with a negative 4i. And you're finished. The fourth one you've got to be a little bit more careful of. A lot of people will look at this product and they'll try to multiply the radicals together under one radical and take the negative times the negative and get a positive. What we need to do here is we need to approach this as they're two separate radicals and rewrite them in terms of imaginary numbers. So the square root of negative 15 we're going to rewrite as I root 15. And the square root of negative 20 we're going to rewrite as I root 20. right? Then you can go ahead and do the multiplication with the radicals. So the I is going to multiply the I, and that's going to give you I squared. And the radicals, as we multiply the radicals by each other, radical 15 times radical 20 is going to give us a square root of 300. Now we come back and we're evaluating that power of I squared, which is a negative 1. And the radical 300 we're going to think of as 100 times 3, so we can take out a 10. And now we can see that the answer is negative 10 radical 3. If you had multiplied the radicals together to begin with and gotten a positive 300, you would not have this negative sign out in your answer. Alright, we're going to move on to the back part and take a look at the calculations we've got left with the last two. In number 5, it looks like we've got really just two binomials that are going to multiply here. And again, that's how we're going to treat this and multiply them just as though they were binomials, but we have to go back and simplify in terms of the powers of I that we got. So we multiply the 6 times the 2, and we get 12. And we multiply the outside parts, and we end up with a negative 30i. And the inside product, a positive 10i. And the last product times the last product, a negative 25i squared. Now, the like terms here can combine, so we've got 12 minus 20i. And the minus 25i squared is the same as negative 25 times negative 1. So we've got 12 minus 20i, adding 25, and we can write the final answer as 37 minus 20i. And that one's finished. Alright, on to the last one. Quick video today. Examples are relatively straightforward. Well, this last example, we've got some binomial expressions multiplying again. This time we're seeing the radicals back in terms of square root of a negative. So the first thing that we'll do is rewrite it so that we pull out that I value from each radical. I radical 28 in the first one, and 2 plus I radical 63 in the second one. And rather than go ahead and try and do the multiplication with the numbers, which are rather large in here, we're going to go down and break those down. So the first expression, we can come back into 5 minus 2i radical 7, since 28 is 4 times 7. And the second one we can break down as 2 plus 3i radical 7. And now would be a little bit more reasonable to come back and do the products. So we've got our first product, 5 times 2 is 10. The outside product, we're going to have a positive 15i radical 7. The inside product's got a negative 4i radical 7. And the last product is going to give us a negative 6i squared radical 49. Alright, and now we have some like radicals in the middle to combine. 10 plus 11i radical 7. And our last expression, we're going to end up with a negative 6 times a negative 1, so that's going to be a positive 6 times the square root of 49, which is 7. So finally we're able to write 10 plus 11i radical 7 plus 42, and the final answer that we get is 52 plus 11i radical 7. And that finishes up our examples for section P9. Tomorrow you will be working on day 9 in class. See you then.